Okay, so that's like the general idea of training. And again, we'll talk about this like in more detail when we talk about the data load and when we cover the PyTorch tutorial for you, right? So that's the next lecture. Now let's try to understand like what different parameters we just covered, and let's connect that with the AlexNet architecture. Okay, so all these hyperparameters, or you can say like the network design parameters, we already know. We know like the shape of the image, we know like all these kernel sizes, how many kernels we are using. So that was one aspect. Okay, so that gives you the network. Now to be able to train it, what you need is, for example, like what activation. So we are using ReLU activation in this AlexNet. And then the dropout is 0.5. You know what dropout is. Batch size was 128. Again, these are the parameters which were used by like that first work which started this deep learning revolution. Okay. And of course, these were like determined empirically. And again, it's not that these are the perfect values which you should follow. It will change with like the data set you're using, with the network you're using. But these are some set of hyperparameters which are used by those researchers. Okay, so they used a batch size of 128, which means like in one batch, there will be 128 images when you compute the loss value and compute the gradients and perform the network of weight update. Okay, so SGD was used. That's like the algorithm we discussed. Momentum was 0.9. Again, we discussed what momentum means. Learning rate was 0.01. Again, you know what learning rate is. That defines like what will be the step size when you make those gradient updates. And the decay for learning rate was like reduced by 10 manually after like the validation accuracy plateaus. What this means is you observe like the validation loss, or you can say accuracy. And if it's not changing, they were reducing like the learning rate by this amount. So the idea here is, as you go closer to your local optima, you don't want to just keep jumping around that point, right? You want to go to that point. So if that is happening, which is like this accuracy plateaus, right? Your loss will not change, your accuracy will not change. Then you reduce the learning rate. Then you start taking like smaller steps. Okay. So then L2 weight decay was this. This is again the regularization term we discussed. So this is like a value for that.